So let's look at a problem that really encompasses all of the topics we've been learning about in terms of nuclear chemistry. So in this problem, it states that strontium-90 undergoes radioactive decay to yttrium-90, and we're asked to write the nuclear decay reaction. So it doesn't specify which reaction, but we know the reactant and we know the product. So we have Sr90, which has atomic number 38, and that goes on to form yttrium-90 with atomic number 39. The only way we can get this reactant is through beta decay, or the decay or the emission of an electron, like so. So you'll see on the reactant side we have 90 mass number. On the product side we also have 90, 38 atomic number on the reactant side, and 39 minus 1 is 38 on the product side. And like I said, this is beta decay. So the next thing we're asked to do is determine the half-life of strontium-90 if 0.953 grams of strontium-90 remains in a block that weighed 1 gram 2 years earlier. So we need to find T1/2. The initial mass or initial number is 1.000 grams, and after some time the block is going to weigh 0.953 grams, and the time is 2 years. So we can use the first order decay reaction, the rate law. Ln of nt over n0 equals minus k times t. And we have everything in this problem except for the rate constant. We're going to need the rate constant in order to find the half-life, which is given by T1/2 equals 0.693 divided by the rate constant k. So the first thing we need to do is solve for k. So we can plug everything in. We'll have ln of 0.953 over 1 equals minus k times 2 years. This is grams and grams. So our grams cancel. Take the natural log of 0.953 divided by 1 and divide by 2, and we'll get k equals minus, k equals 0.024 inverse years. Then we can solve for T1/2. T1/2 equals 0.693 over 0.024 inverse years, and we will end up with 28.9 years for the half-life of strontium-90.